All right, hi everyone. Good evening. I'm Jérôme Petazzoni, and I'm your slightly late speaker tonight, but only 3 minutes late. That's better than I thought. And so for the folks on the back, can you hear me, or should I use that microphone? This means it's okay, or this means I should get the mic? Okay, fine. All right. If my voice goes away and I start speaking less loud and you need me to grab the microphone, don't hesitate to shout at me from the back of the room. That's totally fine. I'm Jérôme Petazzoni. I think my only title to fame, so to speak, is that I spent 7 years at Docker. I joined Docker before it was Docker back in 2011, which means I'm probably one of the few people with like 12 years of Docker production experience, even though Docker is not 12 years old. And also, even though that seems great to have spent 7 years at a startup like Docker, unfortunately, startup years are a little bit like dog years. You know, when you take the age of a dog, you have to multiply by, 7? So I think for startups, it's kind of the same thing. It feels like I spent decades there. Anyway, I quit Docker in 2017, 2018. And since then, I've been like a consultant, teacher, and so on Docker and Kubernetes. And when I'm not doing that, I'm still tinkering with tech toys, and I program music stuff on Raspberry Pis and MIDI controllers, but that's not what I'm going to talk about today. Today, I'm going to first say a few words about TIC, the Tech Internal Conference. I was about to say the TIC conference, but you know, it's like the ATM machine or the PIN number. It's kind of redundant. And then I'm going to talk about Kubernetes development environments, like the main thing. Why would we need one? What is it exactly? And how I make mine, and how maybe you can use what I did for your own benefit. Okay, so one of the big, perks of when I was working at Docker is that when Docker got really popular, I got to meet like a ton of really amazing folks all in the industry. One of them is my friend Nick Shadrin, who was at Enix back then, and I think still is at Enix today. And recently he told me, hey, my friend's organizing like this really cool, like a deep tech conference, like the kind you like, in Berlin. Are you still living in Berlin? I was like, yeah, I am. So he asked me, hey, would you like to be in the program committee? And I was like, yeah, sure. And so I'm going to spend 1 minute to talk about them, because I think it's a really cool event. It's going to be in 3 months. So it's organized by folks who have run many other conferences, look like big numbers, great. You can see on that slide that there is a notable absence of front end, I think, but there is pretty much everything else. There is AI, there is backend, there is like security, etc., etc. And their kind of, motto or signature or whatever is that they do like really the deep technical talks. So yeah, this is an example of great talks at previous editions of the conference. This is the kind of folks who go there. I'm sorry, maybe it's not super visible, but on the right pie chart, the big green chunk is senior and lead specialist, and the red chunk is team leaders. And so I had a friend tell me, well, this is a little bit, like if I'm just a junior in my team, does that mean I shouldn't go to the conference? And I told them, well, you have to learn that we should not confuse correlation and causation. So maybe if you go to the conference, then you will become senior or a team lead. Who knows? Okay, joke aside. Well, it's a normal tech conference with all the normal things you get at tech conferences. I haven't asked my friends why there was a pigeon in front of that lady on one of the pictures, but I just noticed that when I was adding these slides to the deck a couple of days ago, and I thought I need to ask them what the story about the pigeon. I'm very invested into pigeons, because I recently had a pigeon nest on my balcony, and it's charming in the beginning, less so when you need to clean up. Anyway, so yeah, conference. And at some point, just before the break, I'm going to show that QR code again. And basically, my friends asked me as a favor if I could ask you as a favor to fill a form, like to indicate like what kind of stuff you expect, your profile, and so on, to kind of shape the program of the conference, and so on and so on. So If you like my talk, then basically the favor I'm going to ask from you would be to fill that form when I'm done. If you don't like the talk, then I'm not going to ask you any favors, of course. Okay, now to the main point. I'm going to talk about Kubernetes development environments. And really, to tell you the full backstory, when my friends who organized the conference organized that meetup, they asked, hey, we're going to do something at JetBrains, and there's going to be someone from JetBrains talking about all like their development environment stuff. And I was really interested by that talk, but I also have some kind of development environment in a very different way, and I thought, well, I could propose my talk, but the main reason why I'm here is to listen to the second talk. But I'm going to try to share anyway that stuff. So why do we need a Kubernetes development environment? I don't know exactly if there is that same motto in German, but in French we say un mauvais artisan blâme toujours ses outils. So in English it's like, I think, a poor worker blames their tools. And so very often I hear people complain about Kubernetes, like, oh, look, you have to do this super complicated command line just to look at logs, for instance. Like, oh, I'm trying to get the logs of kubeproxy, and you end up having like this 4 commands. First you try to get the logs, but that only gives you the logs of one pod. So then you try again with a selector, but you're like, what selector should I use? So you check the names and the labels of these pods, and finally you can do the command that's going to give you the logs of all the kubeproxy pods, and you're like, yeah, and also, oh, Kubernetes sucks. Or you can have a tool like Stern, and with Stern, on the first try, you get the logs that you wanted with nice little coloration and everything. So it's just like one example of how I think when you work with Kubernetes, or maybe if you work with Kubernetes, it's really important to have the right tools. I think the most basic tool set is probably stuff like kubectl. I'm going to do a tiny bit of audience participation / yoga, and out of curiosity, if you can raise your hands if you are using the tool that I mentioned. So kubectl, so we have some Kubernetes users. Helm, okay, pretty much the same hands, more or less. Stern, oh, way less hands. Okay, so that's actually super cool, because I think if you're working with Kubernetes, you're going to love Stern, because it makes like checking logs much, much, much easier. K9s, okay, that's a bunch of folks. Docker, okay. Completion on these tools. So completion is when you hit tab and it kind of helps you. And sometimes it's super helpful because you're like, what's the name of that particular option? And so you could do, I'm going to check the documentation, or I'm going to do -- help. Or you can just do -- tab, and then it gives you all the possible options. And sometimes, I'm not going that it replaces documentation, because documentation is very important, sometimes even more than the software itself. But it can save a lot of time digging documentation. Who has an alias so that they can run K instead of kubectl? So that's not everyone who was using kubectl, but most people. Yeah, so it's kind of funny. I spent maybe 3 or 4 years being like, no, I won't set up that alias because I can type kubectl in full, and I was perfectly fine with it. And then one day I did it, and then you can never go back, because then you're like, yeah, K space blah blah blah. That's much faster. And each time I'm on a machine where I don't have that alias, it feels like so, I wouldn't say overwhelming, that would be kind of an exaggeration, but I notice it. I thought it would be easy, if you're working on someone else's computer and you have to type kubectl in full, that's not the end of the world, but no, once you get lazy, it's really hard to go back. Now, here is a really big collection of tools, and since this is not an actual yoga class, I'm not going to ask everyone to raise their hands, but I'm just going to mention them quickly because I think maybe some of these tools are going to be interesting for you. There is kubeps1, which basically is the thing showing you the cluster where you are working at the moment, so you can switch clusters. there we go. So for instance, here I'm combining, so I'm using something called Kubernetes and kubectx, which lets you like switch to different clusters. And I also have installed something called FZF, and that's the thing that gives you this kind of little list. And if I try to type something like M-I-N-I-K, okay, there is a lot of stuff called M-I-K, but it's going to kind of narrow down the list. So if you are cursed and are working with hundreds of Kubernetes clusters, that's really easy to find the one that you need. So that's basically kubeps1 to have the little prompt here that reminds me that I'm working on Minikube and not on production. Very important when you're about to delete a namespace or something like that. So kubectx and Kubernetes. There is kubecolor. Kubecolor, same thing. Like if I do kubecolor is going to add color. So for instance, ready is in green, and it doesn't look like much. You know, at the first time I saw that, I was like, yeah, that's some kind of hipster thing for people who use, you know, shells written in Rust and fancy prompts and whatnot. But after I started using it, same thing. I was like, that's actually pretty nice because, for instance, if we look at all the pods, well, first the errors are in red, so it's pretty easy to spot them. And on that cluster, we don't have pending pods, but there is a thing, a pod can be running or pending, and running and pending have exactly the same number of letters. They have ing at the end. The R and the P kind of look the same, so if you're quickly scanning the status of a bunch of pods, there could be a pending one hiding in the middle, and you might not see it, especially, you know, once, like me, you're past 40 years old and you start needing like the fancy glasses so you can, and you have to zoom your terminal and so on. So anyway, the color for that was great. And same thing, once I started using it, I kept using it. I went as far as finding a way to figure out the background color of the terminal, because you need to switch different colors if you have a clear background or a dark background. And I learned that there is a very obscure Xterm sequence that you can use to know the background color of the terminal. So I use that in my scripts so that when I start the terminal, it's like, this is a dark background. I'm going to set kube color theme to dark, or conversely. Anyway, I'm going to go a little bit faster on the other ones, otherwise I won't get to the interesting parts. But on the second line, you have yeah?
What color did you put pending?
What color? Oh, so I didn't change the colors because I have, you know, like my form of artistic expression is music, and so everything that is visual, I'm absolutely really bad at it. So even choosing a color theme, I don't do it because I'm sure I would make the wrong decisions. So I just have this thing where I typically use a white terminal when in presentations like this. And the only moment when I use a dark terminal is when I run a class and I want to show this is the machines that we use for the exercise. And now I'm logged on my local machine, and then I use the dark terminal so the students know that if it doesn't work the same way, it's because I'm on my local machine instead of a remote one. But I didn't change the colors, so for pending, I think it's yellow.
Yeah. I would suggest orange, so it's good in
so that it's, yeah, good idea, orange, yeah, and it's probably more visible than.
It would be yellow. That's, I just want to confirm.
Yeah, and I think on the white background it's probably maybe not orange but brownish, something like that. So on the second line you can see a bunch of tools that kind of have nothing to do with Kubernetes. Curl, HTTPy, like to make HTTP request, FZF, the thing to have like this kind of fancy list, Tmux, like that's just, so it's a terminal multiplexer, which means, oh, I have one terminal. No, now I have two, I have three, you know, and so on. Again, very convenient for me when I do presentations and things like that. Tree, basically you do tree and it shows you like a tree of the files with this, well, this kind of tree display. Again, it doesn't look like much, but when you're explaining something or teaching something and you want to show, hey, these are all the files that we have in this directory, that's super convenient. And of course, Git. And then we have a bunch more tools. I'm going to talk about maybe the fourth line, like JQ, YQ, JQ, YQ, JID, grun. So who knows JQ? Like, okay, probably half of the folks. Grun, almost no one, like what, no one. Okay, so again, super cool stuff because I think JQ is like relatively recent. You know, like 5 years ago, we would have asked maybe like 2 people would be like, yeah, I know JQ, and now it's almost part of the normal DevOps toolkit, etc. So for the folks who don't know JQ, or rather who don't know it yet, with JQ you can do stuff like, basically you can manipulate JSON. So you can do, hey, get the nodes of the cluster in JSON format. So that's going to be this big JSON thing. And then with JQ, I can be like, hey, okay, take, I think it's .items, and then on each element, get me metadata.name, and that's going to extract the names of the nodes. So that's a really like simple, basic example. But each time you have some JSON, either you have a JSON file or you talk to an API that gives you JSON, and you want to manipulate that, extract some fields. JQ can do it. And without having to break out some real programming language. And grun, it's kind of adjacent in a way. Grun is going to transform JSON into something like this. Like for each element in the JSON, it gives us a path like that. And so for instance, if I say, get me the, I don't know, anything about Linux, and then you can do grun -u, I think, to ungrun it. And it's going to regenerate some JSON from that. So same thing, if you need to do some JSON surgery, like replace a few things, remove fields, add fields, super easy. Okay, so then Scopeo and Crane are tools to manipulate images with registries, like download a container image from a registry, etc., etc. So many tools. So basically, when I work on Kubernetes clusters, either because I'm doing some like contract work or when I'm teaching a class, I want to have all that. Not all the time. I'm not saying that every single day I'm going to use the whole toolbox, but I regularly, I would say at least once a month, I'm going to use each of these tools at least once. And so, yeah, okay, the demos, yeah, I did a bunch of demos, so that's cool. So the question is, how do we install the tools? Well, the kind of old-fashioned traditional way is each time you need a tool, each time you hear someone talk about, like I did here, oh, many cool tools. So maybe you're going to install a few of these tools. Maybe sometimes you stumble on a really great list, like there is something called Awesome Kubernetes. Actually, there are a bunch of lists. There is like Awesome Docker, Awesome Kubernetes, there's probably like Awesome DevOps, Awesome Terraform, Awesome, etc. And it's a big list with resources related to that. And so if you go to Awesome Kubernetes, there's going to be hundreds of tools like this. Okay, like I have a laptop here, so I install a bunch of things there, but I also have a computer at home, so I want to make sure the tools are in sync. And then sometimes I work on someone else's machine because we do some pair programming, or sometimes I work for a client where they're like, no, we can't let you connect with your computer, you have to use our computer, etc., etc. So how do we set up that toolbox? And I have one particular use case, which is, like I said, I teach classes. That was before the pandemic, and since the pandemic, it's basically like streaming. And so what I do is that every student gets a Kubernetes cluster. And in fact, now most classes, they get 2 clusters, like one which is kind of on-prem, one which is kind of on-cloud, but that's not the relevant part. The relevant part is that I want to give a really nice environment for the students to learn. Again, like if you start building furniture, you can do it with the little like IKEA orange plastic box, or you can do with a really nice, box with many nice tools and an electric drill and so on and so on. And I want my students to have that experience so that instead of leaving the class being like, oh, that whole Kubernetes is garbage, I want them to feel at least a little bit excited about, yeah, I'm actually going to be productive and efficient and blah, blah, blah. So I want to have all these tools installed and available. And this is how I did it. Basically, I built a container image with all the tools in them. A couple of weeks ago, I gave a talk about exactly how I built the image, because it's like multi-stage, multi-architecture, and it's absolutely disgusting if you look at the Docker file. So I'm not going to talk about that today, but just to give you an example, if we're working with Docker, we can get a shell in that image. With Kubernetes, like you can use a Helm chart, and basically that image, depending on your taste, I would say, then you can get yourself a shell in the container with kubectl exec, or it can also run an SSH server, and you can connect to that SSH server and work with all the tools and the completion and the color and everything. I even have some scripts on top of that, and so just in case, if one day you're running a class, or maybe like a workshop at a conference, or something for your team, who knows, if one day you need to provision a large number of Kubernetes clusters, I have just the right thing for you. All the tools I use for my classes are open source and available on that repo, and so this is an example where you're like, hey, give me 25 Kubernetes clusters on some cloud provider, and it's going to take 5, 10, 15 minutes, depending on the provider, and give you these 25 clusters, and then something you can copy-paste in a Google Docs, like I did here on the right-hand side, with all the like login, password, IP address, and everything. Great. And each time, like, people log into that, and all the tools are there, and it's great. That was also an amazing exercise for me to work with Terraform and with many different cloud providers. I also gave a talk about that, I think it was a couple of years ago. It was like, okay, let's compare 11 cloud providers to see how fast it is to run a Kubernetes cluster and how complex the configuration is. But I'm not going to talk about that today. Okay, so let's skip that. Yeah, that's the output of these scripts. It's fast enough and reliable enough that, for instance, this morning I was teaching a class. The class was starting at 9 a.m. and I started to create the cluster at like 7:45, something like that. Okay, so couple of questions. When doing something like that, why not use namespaces? In Kubernetes, you can create namespaces, so why not just have one cluster? And if I have 25 students, just have 25 namespaces. It works, but when I get to the point where I want to show people how to work with different namespaces, that doesn't work anymore if you only have your own, like, one single namespace. Also, if you want to teach how to work with CRDs and operators, these things act on the level of the whole cluster, so you really need to have your whole cluster. So I try to use, there are many platforms out there like exactly to do that. Like, you get a nice shell in a terminal, and you can, maybe you've used some of these platforms. I'm not going to give names. Some of them are really good, some less good, but basically for my use case, that doesn't really work because the good ones are really expensive to the point that, I wouldn't make money out of my classes anymore. And also, they don't even always have all the teams I wanted anyway. So another thing, okay, do I want to talk about Cluster API? No. Okay, so now, then I decided to kind of go one step further. Because if you follow so far, basically I have this kind of nice Kubernetes development environment, but it's just a fancy way to say, hey, you can SSH into a container and you have a bunch of tools that are ready to use. So it's nice, but not everyone is a fan of the command line, which was a huge shocker for me when I realized that. Like, why would you want to leave the comfort of your terminal and this beautiful everything? I don't know. But some folks prefer other ways to work. And also, like, when you SSH on a remote machine, you edit files with stuff like Nano or VI and Joe. And I typically use VI, but then I have to answer very awkward questions from the students, like, how do you quit that thing? And they want, like, real editors, and I'm like, what do you mean a real editor? So that you can do something like this with AI, So, well, I caved in because nothing is more important to me than the satisfaction and learning experience of my students. I tried a couple of things. First, I was like, hey, what if I give the students the kubeconfig file? So basically, that's the thing that would let them connect to the Kubernetes cluster. No, that was a complete failure because most of the students, especially if it's an intro class to Kubernetes, most of the students don't have kubectl. And then certainly don't have Stern and the completion and color and so on and so on. So absolutely not. Some folks suggested, hey, what if you count on the fact that people will have VS Code, because most people have VS Code these days, which also was a big shocker to me. Like, I don't have VS Code on this machine. But then there are extensions in VS Code to connect with SSH. And so once you set that up, folks could edit files in VS Code, and they would end up editing files on a remote machine. I was like, that sounds perfect. So I tried to set that up. I spent, honestly, days trying to get it to work, and it wouldn't. And I'm like, I don't understand. Everybody does it. I try, and it just doesn't work. I even decided to go as far as following a video tutorial on YouTube, which tells you how desperate I was. And then I thought I was going crazy. I was being gaslit by this thing because I was doing exactly the same thing, clicking on the same buttons, except they had some SSH extension and I didn't. Like typing exactly the same keystrokes. Turns out that on VS Code, it's not exactly open source. And so what most people use is the kind of normal proprietary build of VS Code. And what I used, because I'm like a crazy person using Linux, was an open source build of VS Code. So what? Well, the difference is that Microsoft, in their kind of licensing terms or whatever, you have a marketplace, a little bit like an app store for the extensions for VS Code. And if you have the open source build, you cannot use like Microsoft like special extension store thing. I'm sorry if I don't use the right words for this, because as soon as I found out what was the problem, I decided to erase all knowledge of this from my memory because it was a little bit traumatizing. But the end result is that if you use the proprietary version of VS Code, then it works. You can have the SSH extensions. But still, I was not super happy with the results because that implies that folks need to have VS Code. And if they don't have VS Code, they need to install it. And very often when we go to a training or a workshop or something, we don't really have the time to install stuff on last minute and so on. So I was like, okay, what if I assume that people have a browser on their computer? Who doesn't have a browser on their computer? Yeah, no one. That's what I thought. And so I'm going to tell people to open something in the browser, and that's going to give them VS Code, but running in the browser. Well, I mean, it's not running in the browser. It's running on the machine, and you access it from the browser. So I tried a bunch of different things. There is one called, I don't know if I'm supposed to pronounce Theia or Theia or probably not VIA, but there is that one. There is Eclipse Che, Jupyter, and CodeServer. They all have pros and cons. I ended up using CodeServer. Don't take this as an endorsement. It's more like, well, for the really specific stuff I do, that's the one that worked with the least amount of pain. But the other ones are great too. Like for instance, when I teach Python classes, I'm actually using Jupyter. And if you've used Jupyter, you probably understand why, because it's exactly made for Python, maybe not Python classes, but for Python. So yeah, you take like that whole toolbox I was talking about in the beginning, you add that code server thing, and I'm gonna see if I can try to show it in action real quick. Yep, so let's see. Okay, and then basically, let's see, where am I? Here, and okay, that's going to be a little bit tricky. I need to do that, 30207, and then use that password, I think, all right, and Okay, so that gives us something like this. So it looks a lot like VS Code, or so I'm told, because I don't really use it much. Yeah, I can do stuff like, okay, give me a terminal. There we go, terminal. No, that's not like this maybe, terminal. Help, where's the terminal?
Supposed to be in the bottom somewhere.
Maybe. Bottom left or top right? It's not the same thing. New file. New. Here. There. Terminal. Yes. New terminal. Thank you. Okay. And now I have a terminal. So and we have like. Let's see, I don't even know if that's going to work. Yeah, that even works. Yeah, I can do a key get nodes, and that shows me the nodes. Okay.
Update Kubernetes. You should update to 133.
I think so this is on Linode. I think they might have 132, but maybe not 133 yet. Yeah. That might also be a problem in my Terraform configuration, where it just gets any of the available Kubernetes versions and not the latest one. I should check. So yeah, that's one of the clusters I deployed this morning, as you can see by the uptime, like 11 hours. And so this morning I deployed 25 clusters, because I had 25. Well, I had 24 students plus me 25. So that's what I gave them. Okay, and with, like I said, like all the tools. Okay, sorry, how do I get that full screen? And then there is not exactly a SBOM, but kind of equivalent, like the list of all the tools installed. Sorry if this is not really big. Can I zoom? Yes, kind of. So that's pretty much the tools I was talking about earlier available. Okay, so that's kind of my Kubernetes development environment. The feedback I got was pretty positive. So it was like, okay, that, because for the folks who were here two weeks ago, when I talked about how I built the image, that was really a lot of unpleasant work, but it kind of paid off because, users are happy. That's really the main point. There is a Helm chart, so you can really easily install it on Kubernetes. You can choose if you want the fancy code server thing, or if you want to stick true to the path of the terminal and just opt for pure SSH. It actually runs the two things side by side. Like there is a single pod with two containers, one with SSH, one with code server. But they share the same files, the same home dir, etc., etc. And I even pre-installed the Docker and Kubernetes extensions, so that should be here, I think. Okay, that didn't quite work for some reason, but normally there is the Docker and Kubernetes extension. Maybe anyway. Yeah, I'm using this like very often, not just for the classes, but like I said, whenever I need to work on some Kubernetes cluster with someone else doing some pair programming, after a couple of times, I'm like, what do you mean? You don't have stern, you don't have colors, you don't have completion? Hold on, we're going to approach this like civilized people and get some nice tools. And so we just like literally do one kubectl run command, one kubectl exec, and we have this nice environment. The next thing I want to do is to use collaborative extensions in the VS Code thing. Because apparently it's a thing. Like you can have multiple VS Code, and you can kind of do a four hands thing where one person is typing on their side and another one is typing on the other side, and you're sharing the same windows and everything, which is going to be a big flashback to my college days, like 20 plus years ago when we used Emacs. Anyone heard about Emacs? Yeah, a few people. Very old text editor, but even back then in the 90s, they had something where you could have, share an editor window on multiple machines. And so in the lab rooms in college, that was really great because when you were like, oh shit, we need to turn in this assignment in 2 hours, how are we going to do it? Well, you could have like 3 people literally typing at the same time in the same file, and that worked. A little bit like what Google Docs did 15 years later, basically. Okay, so yeah, that would be my next step because I want to foster collaboration in like positive learning environment, blah, 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 blah. Now, could that be useful for people who are not me? So for instance, you. So first, one thing that we don't always really think about is that if you look at whatever pods we have on a cluster, if you are working, I would say, normally on Kubernetes, you cannot connect to these pods. They are inside the cluster and you are outside, so you cannot talk to them directly. The only way to talk to them is to expose them with a service or maybe use a port forward, like do some extra work. If you are in a shell inside the cluster, you are, how would I say, beyond the moat. Like if you have a castle with the big walls, you are inside, so you can access all that super easily. So if you need to troubleshoot some microservice, that's really convenient. Something else, I have friends who work with lightweight computers like tablets or Chromebooks and so on. And so they use that kind of stuff. But when I told them about the work I did with my image with all these tools, they were like, yeah, that's interesting. And yeah, I just mentioned the pair programming and collaborative editing just before. And maybe there are some other use cases that I didn't think about, in which case I would be really happy to hear about them. Okay, so that's it. As you probably have noticed, there were QR codes embedded in almost all the slides. They will take you to this slides deck, which normally I have made public if I didn't screw up. So obviously all the pinkish links are, well, links, so you can follow all these links to all the resources, the GitHub repos, the list of tools, the whatevers. And like I said, also my friends are organizing this really cool conference in May, and they asked me as a favor to fill that little form survey thing to help them shape that conference. And I think, I think that's it. We're going to have the break, but maybe first questions. Yeah.
Yeah. First of all, thanks for the great talk.
Thank you.
Really cool things.
We do the record.
Okay. No worries. Just 2 things out of that. So first of all, you mentioned a lot of cool use cases, and I think they are just maybe for the people who are here who are more junior. I think a thing like that should never be deployed to production cluster, because obviously if you deploy kubectl and all those things, it's like a big security risk. So please keep that in mind. And second of all, for the development environment that you do for your students. So the container that you have has all the development tools, but how do you spin up all the classes? Because if you spin up like 25 EKS instances, it might be pretty costly. Do you do like K3D on virtual machines, or like
Great question,
you're even as crazy to run Kubernetes inside Kubernetes, or
Right.
like what is he?
Sure. So for the first part, on the security part, it's interesting that you mentioned that. Like I kind of have 2 modes. Well, I'd say 3. One is when I do my classes and I give cluster admin, so that's the Kubernetes equivalent of root, to all the students, because like we said, it's not production, so it's fine. If you break that cluster, I'll give you another one. And that way, that's how we learn. By default, if you run shpod, though, it's going to give you like a non-privileged thing. And so I think even something like kubectl get nodes wouldn't work. You still get the tools, but you would need to bring in your credentials. And in the Helm chart, I added some things so you can indicate which roles and cluster roles you want to give to the user. So sometimes that way you can kind of adjust if you have, to the scenario that would work for you.
That is correct, but so to talk about container hygiene, we always try to find images that are
totally.
as short as possible. So I would even have a complaint if developers are adding things like npm or Maven to production. I mean, so obviously tools like Kubes
Right.
should never end up in a production cluster.
You just touched on extremely like a dirty secret of it. In the beginning, I was like, this is going to be a best practices image where I'm going to put all my knowledge and love and everything. And it was, I don't know, maybe like 200-300 megs. And with all the tools it had, I was like pretty proud of myself. And then you keep adding more and more. And I think when I added Code Server, we broke the 1 gig line, and so now it's like 1.5 gig. And that's why I'm also trying to think about, how can I make that more modular in a way? One thing is that it's based on Alpine, so when you need to install a tool like whatever that I haven't thought about, you can install it like super easily with APK, which I kind of like because it's really fast and it's also pretty light. But that's a really good point. Like, would I want to run that environment on production servers? Maybe not, or maybe in a specific namespace, or it depends. For your other question, like what kind of clusters do I use? It's a very fair question, and at first, when I was the first time I did Kubernetes workshops at conferences, I spun up a bunch. So the way it works is that I spun up a bunch of VMs, and then I use kubeadm to configure the clusters together, because the lowest common denominator is starting VMs. So if you can start VMs, then I can install Kubernetes on them, because sometimes I would do classes, like folks would tell me, we're going to use Google Cloud, or we have like this VMware or OpenStack or whatever, can we teach there? I'm like, yeah, sure. As long as you can give me a list of IP addresses of machines with my SSH key, I can work with that. And then later I started to I would like a real Kubernetes cluster with the Cloud Controller Manager, with a storage class, et cetera. So there was a kind of like scope creep in a way. So that's how now we are at the point where in the repo, that's my public repo, the files I'm going to show you here. So I can automatically spin up clusters on VMs, so kind of basic kubeadm on these providers. And I can do manage Kubernetes on these ones. And then there is a little bit of tooling around it. So when I run the script, I say I have 50 students, and it's going to give me 50 clusters. And so I typically do not use EKS because it's just like super expensive. Just the price of the control plane on EKS is more expensive than the entire cluster on pretty much any other provider. Like for instance, this morning I used Linode because I don't endorse or support or whatever in any way, but it just works. And when I do horrible things to their API, like try to spin up 100 clusters at a time, there are some providers, I'm not going to give names, but some providers, you start 100 clusters and 85 come up and 15 are in some kind of weird state. And then Terraform is like, I'm just going to wait for these 15 clusters. And you're like, no, can you continue? Please, the class is starting in 10 minutes. So can you finish that or timeout? I don't know. So that led me to kind of eliminate some providers because it was just too risky in a way. But I can provision on all of these, and specifically, when I do an intro class, what I do is that I spin up one, not super big, but a little bit chunky cluster, and then I use vCluster on top of that. So that's why here, in the list of supported cloud providers, there is vCluster, which is not really a cloud provider. But the nice thing is that students still get they have the impression that they have a full cluster. There are namespaces, they can install operators, they can do a bunch of things. What they can't do, for instance, is cluster auto-scaling because it's the same nodes for everyone. And they can't tweak the control plane. But that's the kind of state of things. And actually, I think if I go back to git pull, now, okay, I'm not going to be able to show that, but I just added support for Proxmox. So it's like a local private cloud stuff, kind of. And I'm also adding support for Talos, which might speak to the folks. Out of curiosity, so who knows about Proxmox? Few hands. And Talos? Less hands. Okay. Talos seems to be the really cool Kubernetes thing that all the hipsters are doing these days. Joke aside, it seems to be a really nice way to manage Kubernetes control plane and nodes. I started using it a little bit, and I'm like, yeah, that's really solid, immutable. It's an immutable distro behind the scenes. So when you try to map your hard-earned sysadmin knowledge to it, it's bound to not exactly work as intended. But other than that, it's pretty cool. So I don't know, maybe next year I'll give a talk about how to use Talos and Proxmox to do whatever, but not there yet. Other questions? Yeah.
For managing these tools, are you using any versioning like ASDF or MISA or something? How you are managing the versions for the tools when you're building up?
Oh, excellent question. Am I using anything to manage the versions of the tools? No. And you're right, that's at least for some of these tools, like for instance, for kubectl itself, it would be great. But it's a great idea, and I should investigate that to see if that could help with the issue of the image like growing and growing and growing, because if I could use something to not have everything installed, but give people options to install just what they need, perhaps. One really tricky issue is that there is the temptation of having a really super lean bare bones image. But then the problem is that if we need an extra tool, all the students need to install that tool. And then if you're using like a shared cluster, it's like, okay, 25 machines pulling the same stuff at the same time, while if I put it in the image in the beginning, the image is here and it just works directly. And honestly, I haven't solved that yet. I don't know if there is a nice solution to this. Maybe something like a Stargazer, which is a way to dynamically pull bits of the image, but that seems really tricky to set up, so I don't know.
We are using ASDF for multiple reports. We are working with like 50 reports every day, so we go inside, we don't check dependencies, look at all versions, just get the tool versions automatically. So
Okay.
yeah, so
I'm going to put, is it going to, yeah, that's it. Just if people want to see the link and the, yeah.
So what is your opinion about the approach that the Rust forks always do? So they re-implement everything from scratch and put everything into a single binary.
So what do I think of the Rust approach? Honestly, I think that's pretty awesome because the result very often ends up being better than what we had in the beginning. And like I have a friend who, I don't know if he's still at Mozilla, but at least he was at some point at Mozilla, and he told me, I'm doing this thing where I'm taking all the basic tools like ls, cp, and so on, and re-implementing them in Rust. And it's great because I have tests, because all these tools have tests, so I can just run the test on my re-implementation. And I was kind of pissed that I didn't think about it because I wanted to find a way to learn Rust, and I think this is an amazing way because you can start kind of simple and build and build and build. And very often, I'm sure there are exceptions, but very often the outcome is really, really nice. And I think I felt a little bit that way at first when Go came out and we had a bunch of network tools and things like that were like, oh, suddenly things can be not terrible, yay. And I think Rust is doing that again. Maybe the barrier of entry to write and contribute is a little bit higher with Rust, but the final outcome is better for everyone. When I said earlier, like I said something like, oh, people with like fancy prompts in Rust and so on, that was absolutely not like, how do we say, a dig or a jab at that. I think it's great that we have these re-implementations. Yeah.
Okay, Paul, so we got time for one more question, and also some time to pass the survey.
Going once, going twice, going thrice. Thank you.
Okay, then now we got.
Okay, let's start. I hope that the back rows can hear me as well. If not, then just wave at me and I will take the microphone. So today I will mostly talk about remote development. And by that I mean running your development environment somewhere else, not on your local machine, but somewhere else, and connecting to it from your local machine. So with that, I would like to first have a quick poll. So who uses remote development in their daily workflow? Okay. And who at least tried remote development once? Okay, good. Then I hope I can convince you to give it a shot. And for those that already know what it is, maybe you'll get some new ideas. I'm the lead of one of the leads of the CodeCanvas IDE teams. We have multiple teams working on that project, so my team is responsible for the IDE, running the IDEs on the backends and providing connectivity to them. So I'm looking forward to sharing some of my experience and expertise with you. So first of all, I'd like to tell you about a very simple scenario. So suppose you have a powerful computer sitting somewhere in your home or in your office, and then you have a not so powerful laptop that you want to use on the go, and you want to connect to that computer at home remotely. So your whole development environment is there, and what would you need for that to happen? Well, let's for now set aside the challenge of providing the connectivity or exposing your machine at home to the outside world. We know that can be a challenge, but for now, just assume that you already have a remote connection. So the question is, how do you interact with your remote machine? You might turn to some remote desktop solutions like Microsoft RDP if you have Windows, or VNC for Linux, or even if you have an enterprise shop, you might use VDI, virtual desktop infrastructure. But those solutions, they kind of have a common issue. Basically, they work by streaming your screen from the backend to the front end. So this, the stream, it takes quite a lot of bandwidth, and it doesn't really have this perfect latency that you usually require for coding, right? So you start typing something and you see this noticeable delay. This happens because when you type something in, it sends your keystrokes to the backend, but then it has to send the new updated video feed to you, and that takes time. And another issue is that when your connection drops suddenly, you're immediately disconnected from the backend. So you cannot continue working until the connection is reestablished, right? So there has to be something better. And this is where the remote development tools come in. So remote development is not the same as remote desktop. Remote development, this is usually a special protocol that allows your IDE to talk to some backend instance. So it understands your tools, it understands your workflow, and it also is aware of the IDE. It means that when you type something in your editor, it sends just your keystrokes to the backend, and then the backend has its own instance of that editor, and it applies the keystrokes to that backend instance, and then it sends you only the updates. So here, how your editor looks like right now. We've added this set of characters here. So this is, of course, significantly better than just streaming the whole video stream at you. And regarding the, this provides much better latency. And regarding the connection drops, well, if you have an instance of the IDE on your front end, then you can basically continue working with it while the connection is dropped. So this is how it looks like in IntelliJ IDEs. If they work in remote mode, if connection suddenly drops, they show you this banner. No connection to the IDE backend, some changes may be lost, but you can continue typing. So in this case, I've simulated connection drop by just disconnecting the Wi-Fi, and then I typed this class, my class, starting to type, and then it showed me this banner. So when I re-enabled my Wi-Fi, then it looks like this. The IDE got these changes. It added these changes to the backend, and then it showed me, yeah, this is your class. This is, you can see the green line there that shows that these changes are not yet committed. You can see the analysis on the code is done, and it shows me that the class is not used. So this all happens on the back end. So this reconnection happens really seamlessly for the developer. And this is much better experience than using VDI or an RDP solution. So I'd like to show you a very simple demo of how this remote development works in a very simple scenario that I mentioned, but instead of RDP, we will use SSH. And instead of the actual physical machine sitting somewhere, I will just show you a container working locally on my machine with SSH enabled. So I've prepared a special container. It has SSH. It has my public SSH key configured. It has Java for development environment, and it also has a cloned repository. This is a Spring Pet Clinic repository, which is a very generic Java application that allows to show or demonstrate some typical workflows. So yeah, let's see this in action. So basically, what I wanted to show you, is that when you run a computer somewhere else and you can connect to it from your local machine, then you will see an IDE which looks exactly like IntelliJ IDEA. And this is very similar to a local experience, and you will see exactly the same, but all of your builds and all of your indexing will happen on the back end. So with this, I would really need to switch then to the next slide. OK, fine. So this setup, when you connect to your remote machine, is OK when you work alone or on just your personal project. But if you have a team of developers who need exactly the same setup, you probably won't install a physical machine for every one of them. You would want to have some sort of a cloud solution where you can spin up those dev environments for every developer that look exactly the same. Right, so for that, usually what we use is a remote development orchestrator. This is a solution that allows you to run multiple dev environments in the cloud. And this enables, it has several features. First of all, it manages your resources, because if you just run a virtual machine in the cloud, it will consume quite a lot of resources. If you let a lot of developers run multiple virtual machines, they consume even more. So we need some way to shut down development environments when they're not used, to disconnect volumes and convert them to the snapshots, because snapshots in the cloud, they cost significantly less than volumes. And this allows you to manage resources. Next thing is security. So what I would have shown to you is connecting via SSH to your remote machine. And this is actually, in most organizations, this is a security nightmare, because to connect to some machine running on the back end somewhere in your organizational infrastructure is not like something that your security team would allow you to do. And this means that your dev environments have to be available somehow, not by exposing them directly to the internet, but by providing some sort of relay or jump solution. And usually, in most cases, you either use a Bastion server or a jump server, or you can use a relay server, as we do, which passes your connection using the WebSockets. Next thing is provisioning of dev environments. So to provision a dev environment, what I did on my machine, I just created a very simple container with several tools installed. But if you have more tools, if you have a particular configuration, you need some build tools. Like if you use Java, most likely you use Gradle, Maven, whatever. If you use JavaScript, then you need Node.js and other JavaScript tools. Then you need to install all of those on your machine, and you need to somehow manage that configuration. When some updates come up, you need to update them, right? So the job of remote development orchestrator is to keep all of those tools in sync and allow you to use them consistently in the whole development environment. Right, so next is unified configuration. For all of your developers, you want exactly the same configuration. Oh, help is on the way. Не знаю, что произошло, но у меня отключился HDMI. Okay. Thanks a lot. You saved me. Thank you. Right. Yes, exactly. Did you try to switch it on and off again? Crazy. Right, so back to my demo. Anyways, what I wanted to do is I wanted to have a mirroring. Right. Cool. Now I see what you see, and this is good. So let me continue from my SSH example. So what I have here is I've prepared a very simple container. It has, as I said, OpenSSH server and my public key. And when I run it, well, basically that's it. So it's already running on my machine. And to create a dev environment out of this container, the only thing I need is IntelliJ IDE installed on my machine, or that could be even VS Code, or I think most of the dev IDEs support this right now. So in IntelliJ IDEA, I think I will zoom in a little. Right, so that you see it better. In IntelliJ IDEA, you have this remote development tab. And if you go to the SSH tab, here you can connect to your machine that has SSH enabled. The only thing I need to do here is I need to specify my username there. The host would be, in this case, localhost. And the port, I think I've published the port 2222. And now when I click check connection and continue, it will connect to that container and prompt me with the list of different IDEs that I might want to use there. So for instance, I will take the latest release of IntelliJ IDEA, right? And then it asks me for a project directory. Where exactly is my project located? So as you see, it already prompts me with the remote file system. So it already went there and checked out all of the projects there. So when I click Start IDE and connect, what exactly happens right now? So it will download the full IDE, the full IntelliJ IDEA to the backend and run it in a headless mode. Essentially, that means a remote development mode. So this is what I was talking about. So you might think that this is IntelliJ IDEA, but it's actually not. It's just a very thin client that looks like IntelliJ IDEA and feels completely like IntelliJ IDEA, but it's really just a client that shows what's happening on the backend. So I can type here, I can commit, I can list, check out the project, everything works. So a question is, if this is running on the backend somewhere in the container, if I now run this application, this is just a simple web application, how do I connect to that application running inside the container? So in just a few seconds, it should be running. As you may see, it actually builds the project, so it needs some time to build it because it was not yet built. So what IDEA lets me to do is to forward the ports that this application listens to my local machine. So when I click here, this is port 8080, which is used by Spring Pet Clinic application. I say forward and open it browser. Open, and here it is. So this application, once again, is run inside the container, but I just forwarded this port to my computer. Right, so let's get back to my presentation, right? What exactly is missing from here, from this picture? First of all is resource management. So as I said, if you run this in the cloud, then resources can go pretty costly. And you need some way of managing those resources, shutting down inactive dev environments or converting the volumes of dev environments to snapshots. Scalability. Again, if I have a very simple, very small team, they may fit into a small Kubernetes cluster. But if I want to scale this to the whole company, then most likely I would need some way of scaling this infinitely. Provisioning. So again, to build that container, I either have to do it all manually, or I may have some template that I specify. This dev environment should have these and these tools, and when I start it, they already have to be provisioned there. Unified configuration. Again, I want these tools to be exactly the same for all developers in my team. And of course, let's not forget security. I want to make sure that the connection to this dev environment is secure, and there's just no direct connection via SSH. That just won't work. And another important thing is monitoring. So we're not talking only about infrastructure monitoring, but also about monitoring of how this solution gets adopted in your company. Because if you work with remote development in one team, then how do you scale it to different teams? And how do you know if these teams actually use this product, or if they just start working with it, they don't see their favorite tool there, and they say, yeah, we won't use it anymore. So you need to have some sort of monitoring for this. Right, and with that, I'd like to show you the project that we're working on. It's called CodeCanvas, and this is a remote development orchestrator that we heavily use internally at JetBrains, and that can be installed in your own Kubernetes cluster, so in your own AWS account, or in Azure, or in any other cloud, essentially. So you remember that to show you the previous scenario, I had to run the IntelliJ IDEA on my machine. But for this scenario, I don't even need IntelliJ IDEA for myself. I only need this tool that's called JetBrains Gateway. And this essentially takes care of managing your remote development environments for you. So we have this tab here, JetBrains CodeCanvas, this nice little cat here. I can start a new environment. As you see, I've cloned there my repository with Advent of Code solutions. Just for the demo. I will leave all of the other settings as is. And one thing that brings me great joy is this green light here. So this means that this environment is already provisioned for me, and when I click Create New Environment, it will be handed over to me just immediately. I will tell you a bit later how it actually works, but for now, just bear with me. So it says connecting to the IDE. And here it is, starting up. Right, so it starts actually much faster than with the SSH example, because I don't need to download anything on that remote environment. It's already provisioned for me, it's already running, and the only thing that happens is I just get connection to it. So this is really not my local machine. You can see that there is this special plugin here that shows you the CPU load, the memory, the disk on the backend. Other than that, it really looks and feels like just regular IntelliJ IDEA. And yeah, you can also obviously run the applications there and forward the ports just as you would with the SSH example. So how exactly does this fulfill the properties that I mentioned earlier? I'd like to show you the web interface of CodeCanvas. So this is my template that I used to create this new dev environment. And it has a lot of different settings, but I will just focus on some of them. So for instance, I talked about resource management. So how do we ensure that this dev environment doesn't run indefinitely and consume all the resources? And then we get a large bill from AWS. Well, there's, in the lifecycle section, I can specify an activity timeout. Like if I don't do anything within 30 minutes with that dev environment, it will just shut off. And even if I do something, I still have a limit of 10 hours. In 10 hours, it will still be hibernated. So hibernated means I will be able to get access back, but it will be stopped. The volume will be converted to a snapshot, and then when I want to start working with it once again, I will probably need to wait like several seconds, but still I will get it exactly as it was. But it won't consume so much resources. Right, so what else? I talked about provisioning your tools, right? So how do I get some more tools to that dev environment if I need to? I may set up my own dev container image for it. So we already have our a homegrown container image that contains most of the tools that you typically use. But if you need to use a specific tool, you can build your own image, and then you say, please, every time I want to create a dev environment from here, from this template, use this image as the base image, not the one that's provided by JetBrains. What else? I've talked about security. Well, let's get back to my presentation, and I will show you how it actually works and how it fulfills the security promise. Well, this is more or less how CodeCanvas works inside. So you have essentially 2 Kubernetes clusters. In one cluster, we run the CodeCanvas application itself. We run relays there to ensure connectivity. And another cluster, the one that is in the reddish box, this one is the cluster where actually the dev environments are being run. So this is a Kubernetes cluster. We have a special Kubernetes operator there that pulls the tasks from CodeCanvas server. And when I say I want to create a new dev environment, it pulls this task from the server, and then it creates a new dev environment just as a pod with connected volume. And when I say, OK, I want to hibernate that dev environment, it takes that volume, it creates a snapshot, and it puts it into a block storage. So for AWS, that would be S3. For Google Cloud, that would be probably a Google bucket. A main thing that you have snapshots for your Kubernetes cluster. So you may notice that there are no incoming arrows into that reddish cluster with dev environments. This is because there are no incoming connections. You can prohibit them completely. So how exactly do I connect to it from my local machine? And for that, we have these 2 boxes there. It's called jump server and code with me relay. So when I connected to it using gateway, what actually happened is that when that dev environment spinned up, it went to the gateway using the WebSocket connection and said, here I am. Whenever the user connects, please match us. Please connect our data streams. And when I said I want to connect to the dev environment, the gateway went to code with me relay and said, here I am, please connect us. So code with me relay connects those 2 data streams. And we never have to go directly to the dev environment. Jump server works in a very similar way, but for SSH connections. So if you need to connect using SSH, for instance, for downloading some files from dev environment, or maybe you want to use Visual Studio Code or any other editor that works remotely via SSH, then you can use jump server. Essentially, it works the same. So the dev environment creates an SSH tunnel to that jump server. And when I say SSH into my machine, I go through that tunnel to my machine. Again, no direct connections to the dev environment cluster. Right. So while we're on a security topic, there are some additional measures that you want to implement for that cluster to be more secure. First of all, well, obviously, you can connect multiple clusters as dev environment clusters, and you can have different settings for them. So here, for instance, for this connection, we have jump server enabled, because we want to connect to that cluster via SSH. And we can just disable this jump server, and then SSH connection will be prohibited. So if you want your developers only to connect to this cluster using the gateway via WebSockets, you can do it. You don't need to enable SSH. We know that's important because in some companies, SSH may be completely restricted by the security team. We have one more feature, and this is prohibiting remote copy and paste. And this essentially means that when you work with your dev environment, you can copy and paste only within that screen, within that window. And you cannot copy and paste something to your own machine. And this might come in handy if you want to give access to your code, like very secure code, to some external auditor or to some external developers that you don't quite trust. So for that, you can create a separate cluster with this enabled, with this setting enabled, and then they won't be able to copy and paste anything to their machine. So monitoring. I already said that it's important to monitor adoption. And this is just a part of our Grafana dashboard that shows how CodeCanvas is being adopted within JetBrains. So it shows, for instance, how many new users we have every week, or how many environments were created every day. You can see here that someone was busy on the weekends, hopefully not much. But anyways, that helps you to understand some trends within your company. Are your developers satisfied? Do they have everything they want? Or are there any declining trends? Because that would allow us to proactively solve issues with remote development. And last thing I wanted to tell you is one very interesting pattern that we've discovered while we were working on CodeCanvas, and this is short-lived dev environments. So what exactly is short-lived dev environments? Well, if you have a way of provisioning dev environment in seconds, as I've just shown you, and you also can start from clean slate every time, and every dev environment is exactly the same as any other, then the next logical step is, why don't you create a new dev environment for every task? You don't need to create one environment that lives forever, that you install some additional tools there, some additional projects, and so on. Why don't we just create a new environment to do a code review, or to implement a small fix, and then just dispose of it? And this really turns out to change how you work day to day. Because you can have multiple identical environments open at the same time. You don't need to switch your branch and then wait until your IDE picks up the changes, rebuilds everything, and restarts your development containers and so on. This takes time. Why don't you have just several environments open at the same time? You work on a couple of tasks, you fix something in one task, then you wait for it to build, to compile, then switch to another, then you switch to review, and you can do it at the same time. And also, why don't you give other developers in your company who are not part of your team a quick and easy way to contribute to your project? For instance, someone has spotted a bug, and they say, OK, I know how to fix that bug, but I don't want to go through your README with 20 points just to install this project on my machine and then fix that bug and create a merge request. You say, OK, just take a dev environment from our pool, fix this bug, and push it. And that person doesn't need to do anything else. How exactly do we achieve these fast starting dev environments? Well, first thing we do is we prepare warm-up snapshots. So imagine that you have a clean project, you start your IDE on that project, it does some indexing, maybe you build something, and then you create a snapshot of your disk as it is when the IDE already finished indexing everything. And then you can take that snapshot and you can replicate it to multiple dev environments. So whenever a new developer comes and says, I want a new dev environment, you just create it from this snapshot. This is significantly faster than creating a dev environment from scratch. But obviously, this snapshot, it gets old quickly because you work on your project, you change something in the repository. So we have this on schedule. For instance, for our project, we run this warm-up every day. And this seems to be enough. But still, even if you have this warm-up snapshot, creating a new dev environment isn't really that instantaneous. You still have to create a volume out of that snapshot. You have to provision a Kubernetes node, a pod, and so on to connect to it. Maybe it will take, I don't know, 10, 20 seconds. It's not exactly instantaneous. So can we do better? And what we do is we have a standby pool of dev environments. So essentially, if you've specified the template, then you can say run 2 or 3 such dev environments at all times. And whenever someone comes and says, I want to have dev environment, we just hand it over to them. We provision maybe some personal secrets. We assign that dev environment to this person, to this developer, and then the standby pool spins up a new one in replacement of that one dev environment that it just handed over. And this is what I showed you before. And this was this green light there that I'm so glad about. This means that I will get my dev environment immediately. So you can set this pool size, like 2, 3, 10 dev environments at all times. That depends on how often you need new ones. And finally, what you most probably need are lifecycle hooks. So every time you create a new dev environment, you may want to execute some login to external service or provision some additional keys there. Every time you activate it, you may want to run some of your development services, like a Docker Compose file with your development database. So you can put it in a hook. In this case, this is on every activation hook, and I'm starting Docker Compose up for my services. And then every time you connect to that dev environment, you will see your services already running. So you can immediately start coding. But then there's a question, what about personalization? I've talked so much about providing uniform dev environments with exactly the same tools, but you say, okay, I want to have my own theme for the IDE, or my own font, or my own tools. Should I give that up if I switch to remote development? Well, as a matter of fact, you don't need to switch that up. So this, to give that up. So this is a remote development environment that I run on my machine. It has this nice purple color that I like for some reason. And it has this Josefka Nerd font, I think this is, which I also like. And I did not need to set it up on the backend at all. I installed it just once on my local machine, because most of those plugins that provide fonts or themes, they are front-end side plugins. So if you install it on your machine, they will be applied across all development environment that you create. So you already have some level of customization. Yeah, by the way, that's our AI assistant. We tried to solve some Advent of Code's tasks with it. By the way, I don't normally solve Advent of Code tasks with AI assistant, but anyways, this is just for demo. But what if you want to set up your own tools or configuration for them? Well, that is also possible, and you may do this using a very standardized approach, which is .files. Just once again, a quick show of hands. Who has their own .files repository? Okay, several people, nice. Well, even if you don't use remote development, if you don't use many environments, if you have just one, I encourage you to look at this approach and give it a try. Essentially what it is this is your own Git repository with your own configuration, and a very simple script that creates symbolical links to your configuration files to your home directory. That's it. So there's no specific standard. This is just an approach of keeping your configuration files in one place in Git repository, versioned and ready to install on a new machine. Even if you just use one development environment on your laptop, this is still maybe useful because you would be better off recovering from some configuration issues, storing your configuration history, rolling back to last good known configuration, and so on. So this is how my .files repository looks like. Nothing fancy, just a couple of my tools configured there, Vim, ZSH, Ghosty, and so on. So, and then the question is, does CodeCanvas support .files? No. Unfortunately, no, not yet, but we are working on it because this is a very important feature. But even if it doesn't support .files, the only thing that you need to do on every new environment, you just say git clone my .files repository, and then your install script in the same repository, you run it, and it connects all of your configuration files, and boom, your dev environment is configured. Right, so with that, I'd like to conclude. This is, if you want to know more about CodeCanvas, this is the link to our website. It's available. Unfortunately, it's now, if you want to try it, you'd have to fill in the form, but we're working really hard to make it available just by downloading some Helm chart and installing it into your repository. We hope that it will be available soon. And yeah, if you want to connect with me, this is my Blue Sky account. And with that, I'm ready to take your questions. Yes?
Yeah, thanks for the
just a sec.
First of all, thanks for the great talk. Really exciting to hear updates from JetBrains since I've been a long-time customer. However, I'm just a bit curious about the use case for remote development containers, because if you see the current trends in software engineering with the transition to microservice architectures, on the one hand, services become that small that a development container, for example, like a Go or Rust microservice, you could run on the smallest machine, where it is nearly impossible in a modern microservice application to run an end-to-end application locally, because it has way too much dependencies.
Yeah.
So what we actually try to do is encourage developers to do tools like integration testing, contract testing, and then see in a cloud environment how the integration works. And having that said, I'm a bit curious what would be the use case, why I don't want to run my development container locally and instead have it in a cloud, which introduces much more overhead and configuration effort.
Right. So first of all, I think that this is a great case actually for remote development, because first of all, we allow cloning multiple repositories. This is not a problem for CodeCanvas. You can say, okay, I need these 3 microservices or these 5 of all hundreds of microservices that you have.
But you need your Kubernetes manifest and all the dependencies for Kubernetes. For example, I need my Kafka, my hotel, and everything to run.
Right.
I don't want to do end-to-end integration.
Right, and you can do it.
But then you would need a Kubernetes cluster inside a Kubernetes cluster from the use cases you just pointed out.
And we do it like that. So CodeCanvas is a Kubernetes application, right? So to run it in a dev environment, I would have to run a Kubernetes cluster, like a mini kube kind, inside a Kubernetes environment. And this is exactly what I do every day. And this works perfectly.
Okay.
So yeah, the best thing is that you don't need to configure anything on your machine, I would say.
Okay, so you basically have one container that is then spinning up a Kubernetes cluster inside, pulling all Argo manifests and just running them, and
Right.
this is okay.
Yeah.
Okay. Interesting.
The second question was from us.
So a small question. What about indexing of the project? I imagine that since you have those light machines, you might not want to have that happening locally, but remotely. So once the connection drops, then it's gone.
The connection to, but indexing
because
happens
you
on the
mentioned
back
that you want, even without connection, can still keep developing, typing, and then once you reestablish the connection, it will be synchronized.
Right.
So while you're offline, so disconnected from your host,
Right.
you don't have indexing anymore, correct?
I don't have indexing, right. So this is a very short-term solution. So you won't like develop for hours without connection to the backend, obviously, but still you won't immediately be kicked out of your development environment. That's
Yeah.
the point.
Yeah.
So when you are reconnected, then changes that you may have already done, they will be synced to the backend.
Yeah.
But that's, yeah.
Okay, but what I meant by indexing is your indexing of a project on your entities, code completion, and so on.
Yes,
you lose all of that
this happens
while
on the backend, right?
you don't have connection to the host.
No.
So you're all the time synchronizing with the host. So if I got it right, you can work together with a colleague remotely. So both of you connected to the same host.
So this is currently, unfortunately, not implemented in CodeCanvas. So we allow to connect to your ID you're running on your machine with Code With Me. This works, but
Yeah.
Code With Me, unfortunately, not currently works in remote development.
Oh, right.
So we're also working on that.
Yeah.
But currently, this use case is not supported.
Just heads up, my following question would be, if this works, how is then the consolidation of the changes you have done while you were offline when you connect again as your colleague has changed code on the host while you were disconnected?
Well,
if you have any merge screen or anything that can help you solving conflicts. Yeah?
Right. So remote development is actually what our other team at JetBrains does. The whole protocol, the whole like merging of the changes. So I cannot tell you how it's done on the technical level, but I know that they really did a pretty good job. So this is like very cool stuff there. And to my knowledge, it works pretty well.
Folks, any more questions?
while you were showing the demos, I saw dev containers, and I was kind of curious about the use cases because comparing to remote development environments, because while using dev containers, the idea I had in my team was to actually have everything standardized for the whole team, because sometimes we need a tool that's external and everybody has to install it and all the problems we can face. How do you define the use cases to use a remote development environment compared to a dev container instead? When should I choose between each one?
Yeah, so dev containers is also a great tool for standardizing your environment, but yeah, usually run them locally, right? So this is just a container for your tools, so you don't need to install a lot to your machine, just run this container and work with it. And this is a great tool, but what we wanted to achieve here is really this instantaneous feel of running your new dev environment. So this is not exactly what you would get with dev containers. You can run multiple instances of dev containers on your machine, obviously, right? But that would take its toll on your processor or on your memory. So I would say that you can solve some challenges with dev containers, but remote development with an orchestrator really brings you a completely different experience. So this is just, you have to try. So really, I encourage you to try.
Okay, one more question. So you just said, you just said that for your development environments, like inside like a remote container, you'd spin up a Kubernetes cluster for your development, but then you need to use Docker and Docker, which is advised everywhere as a security anti-pattern for the last 5 years, and everybody says this is highly insecure, while you're claiming it as secure development. So I would like to understand that.
Yeah, this is actually a great question because we are currently solving that problem. So for now, currently we use Docker and Docker, right? This is not a great security solution. And some of the customers already told us, yeah, this is all good, but we don't want Docker and Docker. We cannot just enable that. So we're working on a different kind of solution where we run a rootless Docker, and yeah, this will be soon available, I think.
So you're running a rootless Kubernetes cluster inside a Kubernetes pod.
To my knowledge, yes.
This is going to work and behave like production Kubernetes environment, so I can do proper testing. I'm just curious.
Actually, I'm also curious because the team that's doing this migration, they say it will work like perfectly, and I want to believe that. Okay. So yeah, I hope that it will work like that.
Let's program and pray.
Yes. So, any more questions? No?
And we can finish.
Yeah. So. Yeah.